Hello students, welcome to Jules classes.
In today's session, we will discuss the construction, working and applications of an electric motor. After this session, you can also try to make one at home. But why do we need to learn about the electric motor? Because the electric motor is a device which converts electrical energy into mechanical energy, which makes the electric motor an important component in electrical fans, refrigerators, mixers, washing machines, computers, MP3 players, etc. Now, let's see how an electric motor works. Electric motor works on the principle that when a current-carrying conductor is placed in an external magnetic field, it experiences a force. Now let's see the construction of a simple motor in detail. An electric motor consists of a rectangular coil of copper wire. Let's label it as ABCD. This rectangular coil is situated in between the two poles of a magnetic field in such a way that arm AB and CD are perpendicular to the magnetic field. The two ends of this rectangular coil are connected to the two halves of a split ring. Let's label them as P and Q. The inner sides of these halves are insulated and attached to the axle. The external conducting edges of P and Q touch the two conducting stationary brushes X and Y. And these stationary brushes are connected to a source called a battery. So this is how the complete setup of a simple electric motor looks. Now let's understand how it works. When the switch is closed, the current enters into the coil ABCD through X and leaves through Y. Notice that the direction of current is A to B in the arm AB and C to D in the arm CD. That is in the opposite direction to current flow in AB. We know that when a current carrying conductor is placed in an external magnetic field, it experiences a force on it. And the direction of force can be found by using the Fleming's left-hand rule. If we apply the Fleming left-hand rule to the arm AB and CD separately, we can see that the force acting on arm AB pushes it downward while the force acting on CD pushes it upward. As a result of these two forces, the coil and axle rotate anti-clockwise through an axis. At half rotation, Q makes contact with brush X and P makes contact with brush Y, resulting in the direction of current in the coil being reversed. Therefore, the direction of current in the coil will be BCBA. Here, this part of the device has a special name. It is called a commutator. Commutators are used to reverse the direction of the current. Now, since the direction of current in the arms AB and CD is reversed, the direction of force acting on it will also get reversed. You can again verify it using the Fleming left-hand rule. The arm AB of the coil that was pushed downward earlier is now pushed in the upward direction, and the arm CD pushed up earlier is now pushed down. Thus, the coil and axle makes the second half turn in the same direction, and with this, it completes its full rotation. The direction of current is reversed at every half rotation, giving rise to a continuous rotation of coil and to the axle. That's all about working of an electric motor. It converts the electric energy of this battery to the mechanical energy of this coil. Now let's find out if we can increase the power of this electric motor. First, we can try to increase the number of rotations. Can you recall the factors on which the magnetic force in a current-carrying wire depends? They were electric current and the strength of the magnetic field. To increase the electric current, we can increase the number of turns of the coil. We have already seen that if the number of loops are more, a greater force will be experienced. And to increase the strength of the magnetic field, we can either use more powerful magnets or use a soft iron core. Because we know that the presence of the soft iron increases the strength of the magnetic field. All these factors increase the force on the coil and hence the number of rotations. A commercial motor comes with all the above implementations. The permanent magnet is replaced by a powerful electromagnet so that the strength of the magnetic field is high. It uses a large number of turns of the conducting wire in the current carrying coil. And finally, a soft iron core is placed inside the coil. The coil and the soft iron core on which the coil is wound is also called armature. That's all for today. Let's quickly wrap up what we have learned. The electric motor is a device which converts electrical energy into mechanical energy. The electric motor works on the principle that when a current carrying conductor is placed in an external magnetic field, it experiences a force. We saw the important parts in the construction of an electric motor and its working, like how it converts electrical energy into mechanical energy. And we have also seen how the power of an electric motor can be increased. Hope you got to learn new and interesting things today. See you soon in our next session. Keep learning.
Like and share my YouTube videos and also subscribe my YouTube channel Jules Classes by Gaurav Sir. And for more videos, please click on the I button above.